I don't need in order to solve the problem. All right, so let's go ahead and identify some stuff that we think we need. So something here about 2 feet away for every 3 feet. So that seems like a ratio. 2 feet away for every 3 feet. So that's something I might want to pay attention to. Then he found a stick that's 15 feet long, and he can hold it 5 feet above the ground, meaning that that's how high he can reach and safely hold it. And then he knows that he is 8 feet away from where it's going to hit. Okay, so he's 8 feet away. He can hold it 5 feet above the ground, and the stick is 15 feet long. And then there's something about this little ratio deal here, right? So he's got this ratio of 2 feet from the spot for every 3 feet it is high. Okay, so let's go and take a look at this. I've already set up a little diagram here for us to take a look at. So there we go. There's our dude, right? And so what do we have here is, here's the tree, and there's the hive, and here's the guy, and then he's not sure, am I going to be safe? He's like, what? Am I going to be safe or not be safe? So now let's add some stuff. So he's got his stick, right? His stick can, and he said his stick can reach from him, where he's holding it, up to the hive, so that he could knock the hive down. Okay, so there's the stick that he's using. And then what information do they tell us about the stick? Well, the stick is, on the board, yeah. The stick is 15 feet long, so that's 15 feet. Okay, the stick is 15 feet from there to there. Then he says when he knocks it down, the spot that he would knock it down, so if it were falling like this, then he said that he is 8 feet away from that. So that's 8 feet. Okay, so he's 8 feet there. So that's 8 feet. But the stick that he's holding is actually 5 feet above the ground. So from here to here is how high he's holding it off the ground, the stick. So really, the distance from here to here is also 8 feet, because that is going to be just a rectangle straight down. So from here to here is 8 feet, and he's holding it 5 feet off the ground, and he's trying to figure out how tall is that. Okay, so what you might notice here, when I've drawn it like this, when I had the green line down here, that didn't look like a triangle at all because this part is cut off. But if I realize that this distance is going to be the same as the green one down here, then what I've created right here is a right triangle. So my right triangle is going to go from here to there. So this is what we don't know. All right. Okay, so that's pretty cool. Now I can go ahead and do a Pythagorean theorem deal, right? Because I got a right triangle. So I've got L1 squared plus L2 squared equals hypotenuse squared. And the first thing I'm going to check is, I hope this is a 3, 4, 5, right? So 3, 4, 5. Is there any way I can get from a 3 to a 4 to an 8? Yeah. 4 times 2 is 8. So then I'm hoping that 5 times 2 is 15. But unfortunately, 5 times 2 is not 15. So that means it's not a 3, 4, 5. So I might check a 5, 12, 13, but clearly it's not a 5, 12, 13. So at that point, I know I have to just plug it in and do the work. So, okay, so I'm going to go, my L1 squared is x, so that's x squared. My leg 2 is 8 squared, and my hypotenuse is 15 squared. And then this is x squared plus 64 is equal to 225. So then I'm going to subtract 64 from both sides. And I get x squared is equal to 161. And I believe we even had a problem like this earlier. And to this one. So then the next thing I have to do is take the square root of this and the square root of that. So square root of x squared is equal to x. And now here's where we're going to talk about this. So we talked about this before, that 161 is not an exact perfect square. So what I'm going to do to kind of estimate this, although for you guys homework tonight, you could leave it as 161, but we kind of need a number so we can figure out if he's going to be safe or not. So 161, I do know that 144 is a perfect square because that's 12 squared. And I also know that 13 squared is 169. So I know that 161 is somewhere in between 12 squared and 13 squared, right? It's somewhere in between there. And if I look at it, I might say that it looks like it's going to be closer to 13 squared than 12 squared. So I might estimate this as being like, say, 12.8. And that's what that means. It's not exactly right, but it's about 12.8. Okay, so that's about 12.8. So that means from here to here is about 12.8. So is that the height of the beehive? Is the beehive 12.8 feet high? Well, it's 12.8 feet high above here, but from here to here is how far? Well, that's that 5 feet over there. So this side is also 5 feet because I'm holding this stick 5 feet above the ground, which means the total height off the ground, I don't need this any longer. So that means that the total height above the ground is 12.8 plus 5, or 17.8. Okay, so it's 17.8 feet high, right? So what does that mean? Well, now we got to go back and look at this ratio thing. So the ratio here tells me that I have to be 2 feet away from the spot the hive hits for every 3 feet it is above the ground. All right, so I'm going to redraw my thing here because now that's how high it is, which is 17.8 feet. And this is how far I am. I'm 8 feet away, right? Because that's what this is telling me, is that I'm 8 feet away from where it's going to hit, but that is 17 feet above. So now what I'm going to do for ease, because I'm just trying to get a rough estimate here, I'm going to change this to about 18 feet. That's about 18 feet. And it says that for every 2 feet, for every 3 feet high, I need to be 2 feet away. All right? So every 3 feet high, I need to be 2 feet away. So I got to figure out how many 3 feet sections are in 18. Well, from here to here would be 3 feet. That's 1. There's 6 feet. 9, 12, 15, 18. So there's 1, 2, 3, 4, 5, 6 of those. So there are 6 3 feet sections. And for each of these 3 feet sections here, I need to be 2 feet away. So that means I need to be, sorry about that. I need to be 1 section, 2, 3, 4, 5, 6 sections, and each of these are 2 feet. So that's 2, 4, 6, 8, 10, 12. So that means I need to be 12 feet away. Unfortunately, I am only 8 feet away. So that means when this hits the ground here, I'm going to be inside the bees where they're going to be wanting to sting. Okay, so when I am standing here 8 feet away, I need to be 12 feet away. So that means I'm not quite far enough. Okay, so part of the question was, am I far enough? And the answer to that is no, I am not far enough, right? So I'm not far enough. The second part is, how far do you need to be in order to be safe? Like that's not true. The second part is, how long of your stick does it need to be? So if I need to be 12 feet away, and then, so what that's going to be then is, I'm going to slide this over to the side here and use this space. Okay. So I'm still going to hold it 5 feet above the ground. Okay? So I'm still holding it 5 feet above the ground, but this time, this distance here has to be 12 feet, right? And I now know that this height here is about, I'm going to say about 13 feet, because it was 12.8 feet, right? It's about 13 feet, and this one is 12 feet, so then I need to figure out how far does this need to be. So right about now, you might be going, yeah, 12 and 13, that means a 5, 12, 13. And if that's true, if it is a 5, 12, 13, since this side is 12 and this one's 13, that means this one is 5? Does that seem to make sense? And of course it doesn't. So remember, just because you have the 5 and 12 or 12 and 13, they have to be in the right spot. That 13 would need to be over there in order for us to do 5, 12, 13. So I can't do that. So instead, what I'm going to do is Pythagorean theorem. So I have, I have L1 squared plus L2 squared equals hypotenuse squared. Okay, and then I've got 13 squared plus 12 squared equals x squared. That's this one. And this is 169 plus 144 is equal to x squared. And lastly, I'm going to get, what's this? 313? Write that a little better. 313, it looks like, equals x squared. Okay. And finally, square root both sides. So the square root of 313 and the square root of 313, I get x equals, and then the square root of 313 is what I'm going to leave it as. And I know that's not a very satisfying answer, because you're like, what the heck is the square root of 313? But at this point, we haven't talked about how you can estimate these. I talked a little bit about it over here when I did this 12.8, but we haven't really worked on it yet, so you can leave it just like that. If you're curious what it would need to be, you can plug it into a calculator and find out the square root of 313. It's going to be some decimal, so just round it off to the nearest decimal. Okay? All right, so that is like the most involved real world question that we can kind of talk about here. There's lots of stuff going on. As always, remember that you can pause, rewind, and go back and take a look at it if you need to, and see kind of what we were doing. But that's the general question right there. Okay? All right. Hopefully you guys have a great weekend. I will be posting some homework later tonight, and stay healthy.